We will see one more example using one-dimensional array. This is the program. Suppose we have the numbers 2, 3, 5, 7, 11, 13, 17 stored in an array. Write a program to find the square of each of those numbers. So we need to store these numbers in an array and then find the squares of each of these numbers. So the pseudocode is very simple. Store the numbers in the array A, and then for each element a of I in the array A, print a of I into a of I. This is a simple program, but why I have taken this program is to identify the difference between runtime initialization and compile time initialization of an array. So these are the programs we have written previously. The first one is to find the sum of n numbers. Here we are asking for n numbers, and the values inside the array will be known only when you run the program. So now we don't know what are the values stored inside A. When you run the program, you will ask the user to enter the numbers, and then only we will store the value inside A. So this is an example for runtime initialization, because we are initializing the array A only at runtime. This is the second program to find the largest among n numbers. Here also the same case, we are initializing the array only at runtime. So this is the initialization of this array. Here also same thing, we are initializing the array at runtime. We don't know what are the values stored inside the array when you type the program. Reversing array also same thing, we are initializing the array A only at runtime. We don't know what are the values of elements inside A and B right now. It may change each time you run the program. Now we are given a problem where the numbers inside the array are already given. We don't have to ask the user to enter the numbers. So these numbers are already given. So here we can initialize the array when you write the program itself. You don't have to ask the user to enter the numbers. So let's see how we can go about this one. I will copy the program statement and put it as a comment. Save the program. Let's name it array square.c. You see the coloring has some problem. If you look closely, you can see that I didn't close the comment properly. Everything is okay now. Okay. What are the variables we need? We need an array A and we need the I. So let's declare that array int A. Let's put I first and let it be in a separate line so that we can understand it a bit more easier. We can put one more int. We can put in the same line itself, but I am taking it out as a separate line. A of how many numbers are there? 2, 3, 5, 7, 11, 37. 1, 2, 3, 4, 5, 6, 7 numbers are there. So you can declare the array as A7 and then initialize the array at this line itself. We have seen how to do the compile time initialization. Just put the values inside a curly bracket separated by comma. So the values are 2, 3, 5, 7, 11, 13 and 17. So this is what I meant by compile time initialization, because we know what are the values inside A now itself, before running itself. Okay, so we have stored the numbers in the array A. Now as usual, we need to go through each of the elements and then find the square. So we can do that by I is equal to 0, I less than 7, I plus plus, you can print up the square, print up %d, we'll put a space after each square, and then a of I into a of I. So that's it, the program is completed. Hopefully, let's try running the program in the terminal. No errors are there. Then now we will run the program. You can see the squares of the numbers are 490, 925, 49, 121, 169 and 289, but this command line prompt is coming straight after this final square, so we can remove this by putting a new line at the end of the program. Save the program, compile the program once more, run it again. Now it is okay. 4, 9, 25, 49 and so on. So this is an example for compile time initialization. I believe you now understand the difference between runtime initialization and compile time initialization. More often we will use runtime initialization only. This will be used only when we need it on some particular situations. Otherwise we won't be using it.